Hi children, in that previous video we discussed up to cross multiplication, right? So in this video we are going to discuss about that conditions for consistent. Okay, conditions for consistency. So what about that consistent? Here we have that consistent and inconsistent. So consistent means solutions exist. Inconsistent means solutions does not exist. Okay, here which equations we taken? All equations there is no condition, right? Here each and every equation one of that value must be satisfies. Like that we can say why, because I told you that two straight lines, okay, one of that linear equation in two variables means that one represents a straight line as said. So here equation solution we are talking always a solution and a root. What about that one? Here solution and a root, which means here two straight lines we are taking. No, it's intersecting points. Okay, we are which one we are getting here? X value, y value, those are intersecting points of those two lines. That intersecting points we will call them as solutions. We will call it as solutions. So if the given equations are having that solutions, then we can say that those two equations are consistent. If that given equation, given lines are not having solutions, not having intersecting point, then we can say that those two lines are parallel lines only, no? Okay, for example here I taken two lines. These two lines are having that one of that intersecting point here, one of that intersecting point. So this intersecting point we can say that one as a solution set. Okay, here one of the point is there, no, on that graph. At that in the starting first video I told you that graphical representation. In that graphical representation I told you that like this I taken, no, one of that line we got like this. So this is L1, one of the line. So another line if you taken, that one like this passes. So these two are having one of the common point, no, that common point only solution set. So why? Because that one we will call it as a solution set, means which common point we are getting here. That common points x values and y values satisfies the two equations also. Okay, so already we discussed that one in that example I told you, know, in that checking process which answers we got, that answer satisfies that two equations also, no. So and in the same way here which point we got, that point satisfies that two equations also. Okay, so for example here you taken one another point, that is for example 2, 5 and this is for example 5, 4. Okay, this is a 5, 4 point and this is 2, 5. So here this is another point, this is another point. Okay, that equation is having that some other points also satisfying, but those two pairs of equations are having only one of the common point. Here which point is there, which point we got, that point satisfies that equation number 1, and in the same way the same point satisfies that equation number 2 also. Okay, is it clear? So which value, which point satisfies? Here satisfying means only one point we can observe here. So that's why this is having only one solution we can say. Okay, what about these lines here? Here these two are parallel lines. These two also pairs of lines only. But here these two are two different lines and these two are parallel lines. Parallel lines means they never meet at any point, right? They never meet at any point. So they never meet at any point. How we can say that those two are having a common point? It is not possible, no? So that's why these two are not having a common point. Is it clear to you? So that's why here, so this is about that consistent and inconsistent. If that those two lines are having at least one solution, if it exists at least one solution, we can say that those two lines are consistent. Even that is not having at least one solution, we can say those two lines are inconsistent. Okay, so system of equations, what are those? A1x plus b1y plus c1 is equals to 0, and here a2x plus b2y plus c2 is equals to 0. Okay, these two lines are there, no? These two are linear equations in two variables. Okay, now here we will discuss about that homogeneous and non-homogeneous. Homogeneous equations and non-homogeneous equations. Okay, homogeneous and non-homogeneous. So what about that homogeneous and non-homogeneous means? Here the equations which are in the form of a1x plus b1y is equals to 0 and a2x plus b2y is equals to 0. If that equations are in this form, then we can say that those two are homogeneous equations. Actually, what about that homogeneous equations, ma'am? So here homogeneous equations means the power of that variables should be same in that equation. In the given equation, the powers of that variables should be same. Then we can say that given equations are homogeneous equations. So here also a to x power 1, b to y power 1. And we can observe one more thing here, that is there is no constant in these two equations also. Yes or no? So here in these two equations also we can observe that a constant term is not there. So constant term is not there means then we can say these two equations are homogeneous equations. And one more thing, here x and y values there, so x and y values, some values are there, but here these two are not having any common point, any common value not satisfying these two equations. Then also one of the common point satisfies these two equations. What is that? Means 0 comma 0. What is that? 0 comma 0 always satisfies these two equations. Okay, so for example, a1 into 0 plus b1 into 0 is equals to 0. So here a1 into 0, 0 plus b1 into 0, 0. So 0 plus 0 is equals to 0. Is it clear? And in the same way, a2 into 0, 0 plus b2 into 0, 0 is equals to 0. So 0 plus 0 is equals to 0 only, no? So if any point not satisfies that given equations, then only one of the points satisfies, that is 0 comma 0. Okay, 0 comma 0 only satisfies that given equations. This is always satisfies. Yes or no? Yes, this is always satisfies. So that's why this is having at least one solution. Given system of equations are having at least one solution, then we can say that given equations are consistent. So what is the meaning of that consistent? If the given equations are having at least one solution exists, then we can say that given equations are consistent. Now what about that homogeneous? Homogeneous means here the equations which are in the form of a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0. Okay, if that equations are in this form, a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0. Now we will call this type of equations are non-homogeneous equations. Why, madam, here these equations we will call them as non-homogeneous? Because here the power of x is 1 and the power of y is 1, and this constant term we can write it as either x power 0 or y power 0, we can express this one. Okay, here constant is there means we can take that power as 0, no? Okay, so and in the same way here x power 1, y power 1, here powers we can express. For example, here 4 is there, we can write that one as 2 square. Okay, so here constant is there, constant power we can write it as 0, no? Okay, so here these all are not having the same powers, right? These are not having the same powers. That's why we can say this type of equations are non-homogeneous equations. So children, my question is, so still now, up to now, which equations we taken? Okay, we discussed some examples now. 3x minus 5y is equals to minus 1. X minus y is equals to minus 1. Always I taken that example, no? So that equation is related to homogeneous or non-homogeneous? Yes, that is related to non-homogeneous only. Why? Because minus 1 and minus 1 is there. So when you transpose the term into that LHS, we will get that plus 1 and plus 1. So whatever it may be, that is a plus 1 or minus 1, whatever it may be, that is a constant term. So in that equations, constant term is there or not? So constant term is there. So till up to now, which equations we discussed? Those all equations related to non-homogeneous equations. Okay, so simply homogeneous equations means that doesn't contain that any constant term. So we can say that homogeneous equations. Non-homogeneous means constant term is there, then we can say those equations are non-homogeneous equations. And homogeneous equations are always consistent. Why? Because if any value does not exist, always origin satisfies that given equation. So origin means what? Here 0 comma 0 I taken, no, 0 comma 0 is called origin. About this origin we will learn about in the next further classes. Okay, so origin means when you observe that graph, here we are having a intersecting point. This point we can write it as 0 comma 0. So that one only here origin. Okay, so always origin satisfies that given equations, homogeneous equations. So we can say that homogeneous equations are always consistent. Always consistent. Now what about that non-homogeneous equations? Already I told you that graphical representations, no, that is intersecting lines, parallel lines. If you take the two lines intersecting and parallel, when you observe that intersecting lines, here we can observe that one of the intersecting point, so this is having one solution, at least one solution exists, then we can say that that is consistent only. Okay, but here is there any possibility to get that any common solution set here? Here solution set means what? 0, 0 we written in that brackets, no? So we will call this one as a solution set. Okay, so is there any possibility to get that here any solution set? No possibility. So in this case here, this is also non-homogeneous equation only, this is also non-homogeneous equations only, but here solution exists, but here solution is not existing. Okay, so in those two cases also it is there, no, that's why here this we can say this one as consistent and inconsistent, consistent and inconsistent. Okay, so non-homogeneous equations are consistent and inconsistent, and come to that homogeneous equations are always consistent. Is it clear to you about that homogeneous and non-homogeneous, and in the same way consistent and non-consistent? I thought you will get a clarity about this one, right? So next we will see that conditions for consistency. Okay, so conditions for consistency. So the first condition is first one, a1 by a2 not equals to b1 by b2. Okay, condition for consistency for that lines in the form a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0. Okay, if the pair of straight lines are a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0, if that lines are in that form, then here the condition for the first condition is a1 by a2 not equals to b1 by b2. The ratio of the coefficients of x not equals to the ratio of the coefficients of y. Okay, so then we can say that here these two are having a number of solutions. How many solutions exist? Okay, if that condition is a1 by a2 not equals to b1 by b2, then here number of solutions exist means only one solution exists. Only one solution exists. So we can say this one as unique solutions. Okay, unique solution means which lines those two are? Yes, that is graphical representation. Those two are which lines now? By seeing only we can say that here only unique solution. Unique solution means those two are nothing but intersecting lines. Intersecting lines only having that only one solution. Okay, so this is L1, L2 having only one solution. Here one solution existing. One solution existing means here these two are consistent or inconsistent? Those two are consistent or inconsistent? Here one solution existing. One solution existing means those two are consistent. Is it clear to you? One of the solution existing. So that's why we can say that given equations are consistent. When we can say those two are consistent? If the condition is a1 by a2 not equals to b1 by b2. Okay. For example, here the question will come in this form. If the given lines are intersecting lines, then that is having how many solutions? Only one solution exists, no? So what is the condition for intersecting lines? That is a1 by a2 not equals to b1 by b2. That is that condition. Okay, come to that second one, that is a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Okay, here the condition is a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Okay, so here all ratios are equal, then here how many solutions existing means infinite or many solutions. infinite or many solutions exist here. Okay, why madam here infinite or many solutions exist? Why? Because if that the ratios of a1 by a2 is equals to b1 by b2 is equals to c1 by c2, then the given lines are coincident lines. Which lines those two are? Coincident lines, L1, L2. Coincident lines means one of the straight line is exactly overlapped on another straight line. One of the straight line is exactly overlapped on another straight line. Okay, so then we can say that, just observe that why these two are having that infinitely many solutions. Why? Because one of the straight line is having how many points? A straight line has infinitely many points are there. Now here we are taking two straight lines. Now two straight lines also overlapped on each other. Okay, this line is having that infinitely many solutions. Now this line is having infinitely many solutions. Okay, now these two also overlapped on each other. So how many common points are there here? Infinitely many common points are there, no? So that's why here this is having infinitely many solutions are there. Okay, so one solution exists, at least one solution exists means we can say that infinitely more solutions also exist, then also we can say those two are consistent. So here the lines are consistent or not? Consistent only. Why? Because here infinitely many solutions existing. Okay, that's why coincident lines are also consistent. So what is the condition for coincident lines here? That is, if the pair of lines are in the form of a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0, then here the condition for coincident lines is a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Okay, so this is that condition for coincident lines, and here that is consistent, that is having how many solutions means infinitely many solutions. Next, the last condition for that is that system of equations, that is a1 by a2 is equals to b1 by b2 not equals to c1 by c2. Okay, a1 by a2 is equals to b1 by b2 not equals to c1 by c2. Just observe that here the first condition is a1 by a2 not equals to b1 by b2, and here a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Here all are equal, but here x coefficients and y coefficients ratio not equal. But here x coefficients, y coefficients ratios are equal, but those two are not equal to the ratio of constants. Okay, that is the condition. Okay, so here how many solutions are there means no solutions. Like this there means that is not having no solutions. No solutions means simply those two lines are, yes, those two are parallel lines. Okay, here this is one of the line L1 and this is another line L2. So those two are parallel lines. So to that parallel lines, is there having any solutions? No solutions. No solution existing. So that is inconsistent or consistent? Yes, inconsistent only. Is it clear to you? So this is the table form for that conditions of consistency. So if that the condition is a1 by a2 not equals to b1 by b2, then that is related to intersecting lines condition. So intersecting lines are having how many solutions? One solution. So intersecting lines are consistent or inconsistent? Consistent. Next, the condition for coincident lines is a1 by a2 is equals to b1 by b2 is equals to c1 by c2, and coincident lines are having how many solutions means infinitely many solutions. So that is consistent or inconsistent? Consistent. Clear? Next, come to that the last condition, that is a1 by a2 is equals to b1 by b2 not equals to c1 by c2. So here what are those two lines? Then those two lines are parallel lines. So parallel lines then means how many solutions exist? No solutions exist. Why? Because parallel lines, why here no solution exists? Parallel lines never meet at any point. Okay, that's why that is not having any common solution. Okay, so that's why here parallel lines are consistent or inconsistent? inconsistent. So these are that important conditions for consistency. Okay, so here we can say that one more condition that is related to that first one, that is a1 by a2 not equals to b1 by b2. This is also condition for intersecting lines, and in the same way one more condition is there, that is a1 b2 minus a2 b1 not equals to 0. So these two conditions also saying that in those two also related to intersecting lines only. Okay, so these conditions also showing that intersecting lines only. Okay, so in that given question you can observe that if for example this condition is there, that is also related to intersecting, or this one is there means directly we can say that that is intersecting condition. Okay, intersecting lines condition. So this is about that conditions for consistency. So up to here your concept 2 also completed. So in that next video we will discuss about that quadratic equations. Okay, so up to here linear equations completed, no? So once again linear means it's the power of equation should be 1. Okay, next what about that quadratic means, that is having power should be 2. If that equation, if the degree of that equation is 2, then we will call that equation as a quadratic equations. Okay, so we will discuss about that quadratic equation in that next video. Okay.